All right, everybody. Hey, here's your review for part 3 of the Math 3, the final review, I guess. So I'm starting on number 39. And 39 says that the log of b with base 9 equals negative 1. The log of b with base 9 equals negative 1. And I would just say rewrite it in exponential form. So this would be 9 to the negative 1 equals b. And then you have to remember your exponent rules that any number to the negative power is just inverse. So 9 to the negative 1 is really just 1 over 9, and that equals b. That's 39. I'm going to try to stick with the odd numbers, and I'll let you do the even ones for practice. Number 41 says that the log of x with base 4 is 4. So the log of x with base 4 equals 4. And let's again rewrite it in exponential form. That base there is 4. The exponent is 4, because remember, this isolated part here is 4. All right, if I can color code this one is this one, and this one is this one. And what does this equal? This equals x, but what is that? Well, 4 to the 4th power is just 4 times 4 times 4 times 4. That's 16 times 16. That's 256. Number 43. It basically just tells you to keep going, rewrite an exponential form. Okay. I actually think this one is even easier. So this is 43. And it says that the log of 169 with base 3 equals 2, and that is true. 13 squared is, in fact, 169. But all they want is for us to rewrite it in exponential form. So let's do that. So this says 13 squared equals 169. And I'll let you try the other one. You know what? I'm going to make an exception. I'm going to do 44 instead of 45. I said I was going to do all the odd ones. I'm already breaking my rules. That's okay. I'm sure you don't mind. So let us write down number 44. And we have the log. This is 44. We have the log of 1 over 29. Ugh, and that's why I did it. Because it's bull. Anytime it's bull, I feel like I should give some clarity. And of course, I recommend you try it first before you watch me do it. So see if you can correctly re-express this in exponential form. Go! All right, here we go. So remember again that the base is always this bottom part right here. So this is going to be 17. And the exponent is always, the whole point of logarithms is that it isolates the exponent. And so you always know that the number that it equals is the exponent, because that's what you are trying to find. And then that equals the argument, which is 1 over 289. See, that wasn't that blah. It was just normal blah. Number 47. Now we want to go from exponential into logarithmic form. Okay, number 47. It says, running low on battery already. Good thing I have the charger ready to go. I'd hate to have to edit this video and do another take. That would be ugh. I don't like editing. Although I guess I should maybe look into that. Anyway, number 47 says that the 13 to the m power equals n. 13 to the m power equals n. And let us rewrite this in logarithmic form. So that means we have log with base 13. Um, and the exponent, of course, is m. And so it's log of 13n equals m. Because remember, the exponent is isolated. So the exponent goes on the other side of the equal sign. Okay, now that was nice. That was like kind of like introductory stuff. I guess I'll write it exponentially. So a to the b equals some c. That's the same thing as the log of the log of c with base a equals b. That's how you convert between exponential form and logarithmic form, and vice versa. Okay, 49. 49 says that the log of u over v with base 4 needs to be rewritten. I hate how my u's kind of look like my v's. It really is not good. But this is where I taught you guys the rule. I said that the log of b over c with base a equals, and it really doesn't matter what the base is as long as it's the same. It's the log of b over the log of c with base a. What? Okay, now I have to edit it. No, a mistake. What? And just after I made this big sermon about making mistakes last time. Okay, now I really do almost need an editor. I need an editor. Editor, help me out. I only do one take. This is the log of b minus the log of c. Sheesh. Man, that is the division rule. So that means that this is the log of u with base 4, not v, 4 minus the log of v with base 4. That's what this equals. And I guess that's a perfect illustration on you got to be careful and really get it right. Because if you're hasty, you will make a silly mistake like I almost did. Wow. Okay. Should I do the other ones? I'm tempted to do 50 just because I'll just say that 50 is the log of a with base 9 plus the log of b with base 9. I'll just say it and move on. 51, power rule time. Yay, I like power rule. Power rule is actually nice and easy. Log of x to the 4th with base 8. That's the same thing. You just take that exponent, make it a coefficient, and the rest is the same. And that's all you got to do. That is number 51. Let's do 53. Seems kind of blech. In fact, I really don't like it. I'm tempted to do 54, but promise me you try it before I give it away. Here comes 53. 53 says that the log of 11 over 7 cubed, with base 3, they want it expanded, meaning stop with all the fractions. So we know that this is the log of 11 with base 3 minus the log of 7 cubed to the base 3. And we can use the power rule on that. and just write this as log of 11 with base 3 minus 3 times the log of 7 with base 3. Eh, kind of messy. Hoping for something prettier. Um, all right. Promise me you'll try 52 before I do it. I'll do 52, but you have to try it right now before I explain it. So here's 52. 52 says log of x over y with base 9. Oh, and there's an exponent on that, which is 4. And so before I do the subtraction of the logarithms, I'm going to deal with the exponent first. And I'm just going to go ahead and make that the coefficient like that. And so I have 4 log. That's a really ugly log. And this base here is a 9, right? Yes, this is a 9. So that's what it would be. Now I can subtract. So this would be 4 times the log of x with base 9 minus 4 times the log of y with base 9. So it wasn't 4 times the log of x minus the log of y with the base 9. That 4 had to be on both of them. Because if you want to think of it this way, I'm just expanding this, right? And that would give me these parts. And so I would basically have 4 times 4 times the log of x with base 9 minus the log of y with base 9. And you can see that 4 needs to be distributed to each term within the bracket. That's why there's a 4 on one and 4 on the other, and it's not just left off, which I'm sure some of you would be tempted to do. 54, okay, just because I know we all struggle with logarithms, try it, wrestle with it, struggle with it, then come watch this right now and learn how to do it. So 54 says cube root, and that is exactly why I know you want me to help you, because it says cube root. Oh, and I forgot to say log. Log of all this. Do we have a base? We do not have a base, which means it is base 10. That's fine. So did you know that a square root or a cube root or any other root is really just an exponent? We talked about this in exponent rules, but if you have um, some value a, I'm going to call it a. Normally, if it's a 2, we don't write it, but it's basically x to the 1 over a is how you could rewrite this. That means that the square root of x equals x to the 1/2. The cube root of x equals x to the 1/3. That's a 3. Boy, that's an ugly 3. There we go. Right, so the root is the denominator of the exponent. And so here we have a cube root, so that means our denominator in the exponent is going to be 3. So this is just like saying that the log of xyz to the 1/3 power. And using our power rules, I'm just going to write this as 1/3 times the log of xyz. Well, this can be expanded further because each of these variables within the logarithm in the argument there are being multiplied. And so we could actually say this is 1/3 log x plus 1/3 log y plus 1/3 log z. And that's it. That's how you do that one. That was nice. That was a humdinger. That was worth doing. So let's move on. 55. 55 says log of x base 5 plus log of y base 5, 4 times log of y base 5. And they want us to combine it as a single logarithm. Ugh. Ugh. But we can do it. Don't despair. So what we're going to do is, so they're being added, and so that means we have to multiply, but there's a 4 as a coefficient. And so I'm actually going to go backwards and make that back into the exponent within the logarithm. So what I mean is this. I'm going to rewrite 55 as the, you can't even, well, I don't know if you can see the document, but it'd be nice for you to have it handy while I do it. I guess I'll rewrite the question before I go ahead and change stuff. Okay, so this is what the original says. And so what I'm saying is I'm going to take that 4 and make it back into an exponent. So we're going to have the log of x plus log of x base 5 plus the log of y to the 4th base 5. Now they have the same base, same coefficient. Now we can add. And so adding them, of course, is multiplying the arguments. So that means that this equals log base 5 of x times y to the 4th. And that is it. That is the single logarithm. And no, you cannot take that 4 out because it's not x to the 4th power as well. It's the 4th power is only on the y. That's why I can't take that exponent. It's not as if that 4th power is for both of them. It's not that way. And so therefore I can't do the power rule and just take a 4 out and be like, log of xy, 4 times log of xy base 5. No, not. Do not. Got that? Do not. Excellent. Moving on. So 57 then. Solve each equation. Ah, yes. Solving logs. Fun, fun, fun. So we have 57. And it says that the log of k minus 3 with base 3 minus 10 equals -7. It's not as hard as it seems. So the first thing you want to do is just make your life simple, and I'm going to move that 10 to the other side. So I'm going to add 10 to both sides, and I'm going to get log of k minus 3 base 3, log of k minus 3 base 3 equals 3. And that's nice. So in other words, let's rewrite it in exponential form. This means that 3 to the 3rd power equals k minus 3. And we happen to know what 3 to the 3rd power is. That's 27 equals k minus 3. And so we add 3 to both sides, and we get 30 equals k. 59. Again, try it. Every time I do a problem, try it first. Struggle with it, wrestle with it, get it wrong. Then you come back and check it. That's how learning happens. If you just listen to me, you might pick up a few things, but not nearly as much as if you actually try it first. And right or wrong, struggle or no, easy or impossible, you need that initial failure in order to learn, at least to get it better. 59. So we have here log of, oh man, 3x squared base 2 minus log of 3 base 2 equals 4. This might be for the honors class final because actually you guys don't all have the same final. Nevertheless, you need to know these things, but I should just keep my mouth shut. Let us figure this out. So we actually know what log of 3 base 2 is. We could, oh, actually, they have the same base, huh? So we could actually multiply or divide, I should say. Yeah, let's do that because they have the same base. They're being subtracted. That means we divide the arguments. So what that means is we have log base 2, and that's going to give us 3x squared over 3 equals 4. And you'll see here now that it magically goes away. This gives us log of x squared base 2 equals 4. And we can take out with the power rule, we can take the exponent out. So this is actually 2 times log of x base 2 equals 4. Now we can divide both sides by 2, and we get log of x with base 2 equals 2. And that just means 2 squared equals x, and so x is 4. Awesome. Fun. Lots of fun. That was great. I like that. Moving on. 61. 61. Solve each equation. Round your answers to the nearest 10,000th. Oh, man. I need a calculator. Ugh. 61. All right, let's do it. Okay, fine. I'll do whatever you want. Minus 9 times 14 to the m minus 1 equals negative 78. Ugh. Ugh. Well, this is not as hard as it. Well, okay, I wish I should stop saying that. Let's first of all divide by negative 9 because I just want to deal with a single thing. So this equals minus 78 over minus 9. Unfortunately, they are not factors, but minus 78 over minus 9, we can cancel the negative. And also, each of them is divisible by 3. This is 26 times 3, I believe. And this is 3 times 3. So it ends up becoming 8 2/3, so 8.66666. Repeating. And so I guess I'll just write that. 14 to the m minus 1 equals 8.6 repeating. And now I can convert this to a logarithm. There is another trick I really want to show you, but I think I should just refrain from doing that because it might blow your minds. Let's just pretend that it's a normal exponent and just do that. Maybe afterwards I'll blow your minds. So this means that the base is 14. Wow. The log of 14 to some power, which is m minus 1, equals 8.6 repeating. And I can actually find that number and then add 1. And that is exactly what I will do. So I'm going to plug this in, and you should do the same. I have my logarithm calculator with the different base. So the base is 14. And I'm actually going to write 26 over 3 because it's more exact. And I get 0. This is 0.81827. How far did they want it? 864. Okay, I know they didn't want it that far. Let's see what they had. They had to the nearest 10,000th. So I always get these confused. So here's my trick to remember: 10th, 100th, 1000th, 10,000th. So this is where they want it. But that means you have to round because this one will round it. So actually, that would be 0.8183 equals m minus 1. And so we add 1 to both sides. And I'm just going to change this decimal here and make it 1. So the thing that's going to blow your mind that I was talking about is that I'm just going to make some room here. If you have 14 to the m minus 1, m, not n, did you know that that's actually 14 to the m over 14? Because remember, this has a 1 and it's being subtracted. And so what I was thinking of is I'm just going to multiply both sides by 14, and I'm going to end up with 14 to the m equals 14 times 8.6, repeating. And that's it. It would have worked. I mean, it's just a different log that I punch in, but the result is the same. I still get the same answer for m. I'm not going to do all that out. I'm just going to move on. So now let us go to what number was that? That was number 61. Okay, so 63. 63. Actually, no, these are easy. So the original says h of n equals 2n minus 2. G of n equals n cubed minus n. And they want to know h of g of n. Well, so this is what we call a composite function, and you always start on the very inside. So I hope you remember me talking about this. But basically, we're just going to punch in g of n. Now, there's no numbers here. No, we're not plugging in like 2 or 3 or 4. We're plugging in a variable, but it should be okay. The first step is just to start with substitution and not worry about the future. Just worry about the current step and do that. So this is going to give me h of g of n, which is, I'll make it blue, right, this stuff right here, n cubed minus n. So that's step 1. Now, we have to plug this in for this n right here. So h of n equals, okay, this stuff right here, right, in green, 2 times n minus 2. Right, this was n, but we know that this is going to be our new n. And so instead of n, we plug in n cubed minus n, and that will give us what we want. So this equals 2n cubed minus 2n minus 2. And that's all you can do. That's already simplified. It is done. That is all. 65. Again, try these on your own before I do them. 65 says f of x equals 3x plus 4. And g of x equals minus 2x cubed minus x squared. Ugh. minus 2x cubed minus x squared. Just double checking. Everything's copied down correctly. Good. So they want f circle g of x. And what the heck does that mean? Because you probably forgot. Fog. It's not fog. It's actually composite f of g. I forget how they say it. Composite fg or f composite g, something like that. And what it basically means, it just means f of g of x. Like that. That's all it means. And so basically, it's just like the last problem. We're going to have our g of x equal this right here. And so that equals f of g of x, which we know to be minus 2x cubed minus x squared. And from there, we will plug this into the f of x. And remember, f of x equals, let me not do it this way. You take this, and we're going to plug this stuff right here in for this x. So this equals 3 times x plus 4, but our x is not x anymore. Our x is now minus 2x cubed minus x squared. And so that will give me minus 6x cubed minus 3x squared plus 4. Nothing to do, nothing to simplify. That is correct. That is our answer for number 65. Getting towards the finish. 67. Please try this one. You really, please right now, try this on your own. See if you remember how to do it, because it is important to know. Let me recopy it here in case you don't have it handy. It says a rabbit hops in a parabolic arc. Okay. It hops in a parabolic arc. That's great. I'm happy for it. The jump has a width of 10 feet. So this right here is at 10. So the midpoint is at 5, not to scale. I'm sorry. So this right here is going to be width 5. And a height of 3 feet. So this is 3. So this point right here is 5, 3. And they want the full equation of the arc. Go. All right, here we go. So remember how we have our business with the HK business? And basically it said that y equals x minus h squared plus k. Oh, and then there's also an a in front. Almost forgot. And we actually know some things here. This point is hk. This is my h, and this is my k. So the first thing I'm going to do is I'm going to plug that in for the hk, and then I just need to find the a value. So let's do that. So we have y equals a times x minus h, which is 5, squared plus k, which is 3. And now you're like, well, okay, but how do I find a? Easy. You plug in a point on the parabola. Anything other than the vertex will work. So I usually start either with the origin or with the landing point. In this case, I'll go with the landing point. I'm sorry, it doesn't look quite like a parabola. It's supposed to be a parabola. This is not quite smoothed off. It should be more like that. In any case, let's plug in 10, 0. So that means that 10, 0, this point right here, let me actually make it a different color. 10, 0, this point is going to be my x and my y. And so my y is 0, and I'm going to keep the rest of this. My x is 10. 10 minus 5. And then the whole thing is squared plus 3. And solve for a, which I forgot to write. You know what? Let me that's better. Okay, so at that point, now I just resolve that. So I'm just gonna use a different color just because tired of switching colors all the time. 0 equals a times 5 squared plus 3. So in other words, 0 equals 25a plus 3. Subtract 3 on both sides. Minus 3 is 25a. Divide both sides by 25, and we have minus 3 over 25 equals a. If you want it in decimal form, it's nice and convenient. It's actually negative 0.12 because I just multiplied top and bottom by 4. And so I get minus 12 over 100, so that's minus 0.12. And so the full equation is going to be y equals, and I'll accept either fraction or decimal. I'm in decimal mood for some reason right now, so I'll keep it decimal, times x minus h, which was 5, squared plus k, which was 3. And that is how you solve it. 69. Solve each equation, round your answers to the nearest 10,000th. Oh, lordy. And they gave us E. I love it. I love it. It's great. So this is number 69, and we have e to the 5p equals 43. And they want us to solve this? What do you mean solve this? How can I solve this? Well, we're going to do a logarithm. Okay, so this is going to be a log. The base is e, and more on that in just a second. The argument is 43, and it equals 5p. But remember that when you have a base of e, we're actually supposed to write it as ln 43, like that, equals 5p. That is actually how you're supposed to write it. We didn't do too much of this in class, but I did talk about it that one day. And so now we're ready for the calculator. So I'm going to punch in ln 43 and see what we get. So functions ln 43, and that is equal to 3.7612000, blah, 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 blah. Lots of stuff. That's good enough. And let's see, this equals 5p. So I have to divide this by 5. So I'm just going to take all this and divide it by 5. And I end up getting 0. And how many digits do they want again? They want 10,000th. So 4 digits after the 0. So that's good because that's what I got. This is 0.7522 and theoretically 400, but good enough. And that equals P, and that is the answer. And that is how you do it, my friends. Just don't be intimidated. Remember what you know. Plug in what you know. Do it out. Don't get frustrated and give up. Okay, we're almost done. Wow. Let's see here. 71. That's our last one. Yay, that's my last odd question. That's the last one I'm doing. So 71. Here we go. It says 6 times 17 to the a minus 7 all equals 8. And again, try it first. Try it first. See how you do. First thing, I want to divide by 6. So 17 to the a minus 7 equals 8 over 6, otherwise known as 4/3. Now I am ready for logarithms. And so I will say this is the log base 17 4/3, and this equals a minus 7. Calculator time. So here we go. We have the log. Whoops, I forgot to change the base. No. Let's redo that. We are going to have the log with the a underneath, and we have 17 as our base, and we have 4 over 3 in here, and no, I'm not going to subtract. I'm just going to do it. And that gives me 0.101 5391 something. Okay. Equals a minus 7. So we just add 7 to both sides. And that's just going to change this right here. And that's my answer. And that is what A is. But how many digits do they want? They want 4 again, right? 10,000th? Yes. So we just cut this business off. And we got it. And that's it. So good luck, everybody. Stay tuned to the chat. The stream. I'm going to see if there's anything else. Really, there's not much else. I would just look over your old notes and the old videos if there are any, and review those. Email me if you need help. I probably won't answer over the weekend, so that kind of sucks for Monday people. But there you go. Enjoy. Have fun. Hopefully it all recorded. Okay, yes.